Okay, number 16 on page 5 says, write an equation of the line containing the point 2, -1, and parallel to the line 5x minus 7y equals 8. This problem is talking about two lines. They're asking you to consider that one line is already defined as 5x minus 7y equals 8. Envision a line that it runs parallel to that line, only the second line runs through the point 2, 1. You are to write an equation for the second line that is parallel to 5x minus 7y equals 8. What we know about parallel lines is that they have the same slope. Okay, so perpendicular lines have slopes that are both opposite and reciprocal, or flipped. For instance, if you have a slope of 3/4, a perpendicular line would have a slope of -4/3. All right, but we're working with parallel here. So we take our first line, and what we can do is use that to find the slope of the first line, which is the same as the slope of the second line. And then we will have the slope of our second line and a point on our second line, and we can define the equation for the line that way. Okay, so 5x minus 7y equals 8. Let's get the y term by itself, and by subtracting 5x from both sides, and then dividing everything by -7 to get the y by itself. Oops, so that should be minus. Okay, so here's the equation of the first line written into y equals mx plus b format, where the slope is 5/7. That is all we need from this first line, so we don't have to consider it anymore. We're going to pull that slope into our second line. So we are looking for a y equals mx plus b, where the slope is 5/7. Now you can find this line using the point slope formula. You have the slope and you have a point 2, -1 that the line goes through. I told you back in an earlier video that there were two ways to find that line. One was using the point slope formula, and the other is just using this formula right here and substituting 2 and -1 for y and x. So instead of y, we have -1 equals 5/7, and then x would be 2, but we're going to write it as a fraction. Okay, now you see you have this equation, and the only thing you don't know is b, so you can solve for b. All right, we're going to multiply numerators and multiply denominators, and then we're going to subtract 10/7 from both sides to find b. Okay, now of course, since we have a fraction, we have to convert that fraction, the whole number, into a fraction and find a common denominator, which would be 7, not 10, and multiply it. So we're taking this one, -1, and making it a fraction and multiplying it by another one, but in the form of 7/7, so that we can have the same denominator as -10/7, and then we can combine our fractions. So you see, we now have two fractions with the denominator of 7. So we've now found that b is -17/7, and we have m up here to be 5/7. That's all we need to write y equals 5/7 x. minus 17/7. And that is the equation of a line parallel to the line that was given. And this line runs through the point that was given, which is x equals 2, y equals -1. If the question had asked you to find a line perpendicular, the only different thing you would have done is when you found this slope of 5/7, you would have flipped it and made it -7/5. Flipped it and made it negative and used that up here instead of 5/7. Now we move to chapter 18 where we have inequalities. And so it says solve this equation. So let's do that. First we're going to distribute the negative sign, or you could think of it as -1, through that parentheses, and here we're going to distribute the 6 through the parentheses. Next we are going to combine like terms. And then we are going to get the x's on one side by adding 2x. And subtracting 6. And then dividing by 5. If we'd had to divide by a negative number, that would have reversed the direction of this inequality. But since we're dividing by a positive number, it doesn't reverse it. However, we need x on the left. We don't want 2 in relation to x. We want x in relation to 2. When you do that, when you move them back and forth, you still have to point to the same thing that you were pointing to before, which in this case was the 2. So x is greater than or equal to 2. That's one way you can express the answer. The other is graphically. Here's 2. X is greater than or equal to, so we use a bracket rather than a parentheses because we have an equal component. And then everything larger than 2 gets shaded, and that is the graph of x is greater than or equal to 2. And the interval is x, you graph it, and then you look at your graph and write, I see a bracket, I see a 2, and then I see an infinity. And infinity always goes with the parentheses. So now you have the interval of the graph and the x is greater than or equal to 2 all say the same thing. In number 18, you have a 3-part inequality. So what you do to one part of it, you have to do to all parts. We want the y by itself, so we are going to subtract a 4 from everything. And that gives us -3 is less than 3y is less than or equal to 15. And then we divide everything by 3 to get the y by itself, and we get -1 is less than y is less than or equal to 5. Okay, so what we're saying is, on a number line where we have -1, 0, and all the way up to 5, y is in between -1 and 5. So let's go ahead and shade that in. On the -1 side, -1 is less than y, not less than or equal to, so we do a parentheses. And on the 5 side, y is less than or equal to 5, so we do a bracket. And that is, let me make sure that looks like a parentheses. And that is what the graph looks like. Once we do the graph, we can write the interval. We see a parentheses, we write the parentheses. Then we write the -1. Look at the other end of the solution set, which is 5, and we see a bracket. So there we have our answers in 3 different forms. In number 19, we have a problem involving the word or. I'm going to work this as if it's an or, and then I'm going to work it as if it's an and, so that you see the difference. But in an or situation, you're going to end up with 2 graphs, and everything that's on either graph is in your solution. I'll show you what that looks like in a minute. If x plus 3 is negative 2, we can subtract 3 from both sides, and x is less than negative 5. If x plus 3 is greater than 2, we can also subtract 3 from both sides, and x is greater than negative 1. Okay, so here's, let's say x is less than negative 5, so we're going to do negative 5 and negative 1, 0's over here somewhere. If x is less than negative 5, that graph looks like this. And then x greater than negative 1 looks like this. Negative 1 there. Okay, so those are the separate graphs. That's not the answer, that's just the graphs that we are comparing. If our answer could be x is less than negative 5 or x is greater than negative 1, then that means our answer, a possible answer, would be in this area or in this area. So that's what our graph would look like. And the way we write that is we again write what we see in the shaded areas. The shaded area starts at negative infinity and runs to negative 5. Infinity always has a parenthesis. The 5 has a parenthesis. Now, we're including both areas, so we're uniting both areas. That's a U. And then we see a parenthesis, negative 1, and then an infinity with a parenthesis. So this is the way you write an interval for an interrupted graph like that. Okay, so that's or. If it had been and, then we would look on this graph here. Our answer would have to be on this graph and on this graph. And if you line these up, you see that the areas that have shading on both graphs don't exist. There's no place on a number line where you get something that's here and also here. So since those two graphs don't overlap, then that means there is no solution. Your answer is just a plain old blank number line and there is no solution. On number 20 we get into absolute values, which are distances. So this is saying that 2x minus 3 represents a distance, and it's a distance that is 4 units away from 0. So 2x minus 3 might be 4 units in the positive direction or in the negative direction. So those are the two situations we have to consider to solve this. So in the first case, we need to isolate x like we have been all semester. And we get x is negative 1/2. And in the second case, x equals 7/2. So those are our solutions, and you would write that negative 1/2, 7/2. If you were to plot it, you would plot negative 1/2, 7/2. Just dots because it's an equal sign, not an inequality. Also note, the solution is two distinct points. It's not an interval. It's not a shaded area. That is because of the equal sign in the problem. So your answer is going to be two distinct answers separated with a comma. It's not going to be an interval with parentheses or brackets. Okay, in this case, you have an absolute value is less than 5. It's not equal to, so we will be dealing in intervals. Okay, let's look for a minute